Hey everybody, so today I want to talk about this thing called the theory of island biogeography. And this is going to be the last topic that's included on your test that's on Friday. So the test on Friday is going to be a Google form, it's going to be open notes, and it'll include things like community ecology, it'll include evolution, it'll include what we talked about last week with fire and ecological succession. And then finally the last topic it'll talk about is this theory of island biogeography. The test will not be as difficult as the last one. There aren't as many things that I can make a graph about for these different topics. And it'll be around 40 to 50 multiple choice questions. So let's talk about this theory of island biogeography. So back in the day, back in the 1960s or 70s or so, there are two really famous ecologists, and their names are MacArthur and Wilson. And they had this really big question. They said, what determines the number of species that you would find on an island? Why do some islands have tons of species? Why do some islands have no species? So they proposed this theory after doing a ton of research, and they called it the species equilibrium model, or the theory of island biogeography. So biogeography is just this fancy word that means why are certain species found somewhere and not others? And I took an entire class at Clemson about this. It's really, really interesting, and if you're interested, we can talk more about it in person. So they said that there are two different factors that can affect the number of species that you'll find on an island. And the first one is going to be the rate of immigration of species to that island. And then the second one is going to be the rate at which species become extinct on that island. So the rate of immigration of species to the island is going to really depend on how close to the mainland is that island. And then the rate at which species become extinct on the island is really going to be impacted by the size of the island, like how big is the island and how many ecological niches, whatever, are there to fill for these different organisms. So this graph here is kind of like the supply and demand curves if you're in economics, and there is some sort of equilibrium number here where these two are going to intersect, and this is just a picture from your textbook. Alright, so let's talk about this theory of island biogeography, and keep in mind this is just a model that they have created, these two scientists, MacArthur and Wilson. So they say that the extinction rate and the immigration rate are affected by these two important features of the island. So the size is going to be the first one, and then the next one is going to be the distance from the mainland. So if you have a really small islands, then generally they have lower immigration rate and higher extinction rates. And the reason for that is because if you're a smaller island, most likely it's going to be really hard for different species like birds or mammals or something like that to hit you. Because you can think about it as throwing, darts at a dartboard. If you are trying to hit a really big target, and if you're trying to hit a really small target. So let's say that, in this example or this metaphor, the birds are trying to get to a new island. If it's a really small island, they're going to have less of a chance of hitting it. And if the island is really small, there's going to be less niches, however you want to say it, because it is a small island. It's going to have really narrow ranges for species to do. So then large islands generally have higher immigration rates because it's easier to hit them. If you're a bird or some other animal like flying to a new island, it's going to be easier for you to hit that. And then they're going to have less niches, however you want to say it. Have more niches because they're larger islands. I'm sorry, I misspoke. So again, small islands, lower immigration rates, higher extinction rates. Large islands have higher immigration rates and lower extinction rates. So if you look at this graph here on the next one, there are basically, different options here. So this is immigration for a large island, this is immigration for a small island, extinction for a small island, and extinction for a large island. So if you look at there's basically there's four different equilibrium numbers, if you will. So this is showing you that on a large island and the extinction rate of a small island, this is going to be the equilibrium number of species. If you have immigration on a large island and extinction on a large island, then it's going to be a higher number of species, and so on and so forth. So this is showing you here, this is showing basically immigration near the island, or on a near island, and then immigration on a far island. So let's say that we have a really large island that is close to the continent or the mainland, kind of like Madagascar, right? So Madagascar is known for its tons of species, mainly because it's an island that's close to the mainland, and because it's a tropical rainforest, because it's found pretty close to the equator. So this last slide that I wanted to show you, it just says, imagine two islands of different sizes and distances from the mainland. So this here, this little squiggly line that I drew here, this is the mainland. It says predict which would show the greatest species diversity and defend your position. So let's say that there are two islands here. This is a larger island and this is a smaller island. This one is closer to the mainland. This one's further away from the mainland, but this one is almost, 5 or 6 times this island down here. So which one do you think would have the greater species diversity? If I were going to have to pick, I would say this one here. Because again, it's not that much further from the mainland as this one. And if you go to this island, there's probably going to be more opportunities for you there. There's probably going to be more roles or niches, however you want to say it, for you to, do. As opposed to this island here, there's probably less niches, although it is closer to the mainland. And that's really it for this one. I know this video was really short. That's why I chose to do it as a video instead of doing it in class. So just kind of a recap or a review. These two scientists back in the day, like the 1960s and 1970s, MacArthur and Wilson, they said that an island's number of species is going to be dependent on the rate of extinction and the rate of immigration. And the rate of immigration is going to be affected by, or both of them are really going to be affected by, how far is the island from the mainland and how big is the island. And again, larger islands that are closer to the mainland should have the highest number of species, and smaller islands that are really far from the mainland should have the lowest number of species. Alright, so that's it for me. I kept it under 10 minutes today. And if you have any questions, give me a comment or send me an email. I hope you have a great day.